Okay, as we finish up lesson 1.8, we have two learning goals. Our first one on the front side of our notes that we're going to do here together today are I can write rates and unit rates. Okay, these are like very common in our everyday world. A rate is a ratio of two quantities with different units. So when we're comparing two quantities and they are measured in different units, we say we have a rate. When we write rates, oftentimes they make more sense to us and they're more practical when they are written as unit rates. So we take a rate, it's comparing two quantities that have different units of measure, and we write them as unit rates, which really just means this. The second quantity is 1 unit. So the first quantity is being compared to 1 unit of the second quantity. Examples. Notice in all of those it's 1, 1, 1 downstairs. 1 gallon, 1 hour, 1 gallon. So when we are talking about unit rates, it's per 1. So how many quarts in 1 gallon? 4. 4. That is a unit rate. 4 quarts per gallon. In fact, this is why we would probably write that. Instead of having the 1 there, we would write it, ditching that 1 and saying this is quarts per gallon. There are 4 quarts per gallon. How many minutes in an hour? 60. Okay? And again, we can ditch that 1 downstairs. We know it's there. We have 60 minutes per hour. Okay? And again, we can't just put M because that might mean meters. We can't just put MI because that would mean miles. So we have to put MIN for minutes. Okay? And then how many miles in 1 gallon or per 1 gallon? I know, you're scrunching up your face like, what? Are you kidding me? It depends, doesn't it? On what? What you're driving, what you're flying, what you're, okay? So we'll call it X. But that's a very typical one also. We talk about miles per gallon. Miles per gallon, we oftentimes. Now, there is a shorter abbreviation for that, MI over GAL. Anybody know what the shorter even abbreviation for miles per gallon is? No? Okay. It can also be written like this, MPG. MPG. That does not mean meters in that case. So that's a common way to write miles per gallon, also MPG. Okay, so when we have unit rates, which is the typical way we write them, we talk about them per 1 unit. Give me some other examples of some typical unit rates in our everyday world that we talk about. Yeah.
How many inches are in a foot?
Okay, inches per foot. Yeah.
How many hours are in a day?
How many hours in a day? Hours per day. How many hours are there per day? 24. Anybody have a job? You do, Jason, if you do, okay. How do you get paid? Dollars per hour. You probably at this point in your life get paid by the hour, don't you? Dollars per hour, okay. So can we think of any others? Anybody driving here yet? Oh, you do. Think of something with driving other than miles per gallon. Andrew?
Miles per hour.
Miles per hour. The speed you are driving. You're driving so many miles per 1 hour. We talk about miles per hour. Okay, so there's lots of unit rates. Okay, here's the thing we have to be careful of, especially when we're working with word problems. When we are setting up our rates, we have to set them up in a proper order. In other words, we have to have them make sense. Okay? So when we are told to find something, what we first want to zero in on is what do they want it expressed as? And that's really important that we make sure that we look for that. So in this number 1, if 12 gallons of gasoline were used to go a distance of 222 miles, what is the number of miles per gallon? So the important thing, first of all, for us to recognize is this is how they want it. Miles per gallon. So miles has to be the numerator or the denominator? It has to be the numerator in our ratio, also known as a rate. So here's what I want you guys to do when you set these up. You can use your calculators, but you will show me this. 222 miles over 12 gallons. And then you will say, what is that? How many miles per gallon did this particular vehicle get? So when we're setting up our rates, we'll show those different units of measure, because then we can say, make sure that we're setting it up properly. Because sometimes we're not really sure what number should be getting divided by what number. Sometimes we just always automatically think the bigger number should be divided by the smaller number, not necessarily. So what do we get? We get Devin?
18 and a half miles per gallon.
18 and a half. So is that a nice decimal?
Yes.
It came out to exactly that. Okay, 18 and a half or 18 and 5/10 miles per gallon. Or in other words, the label that we have right there. So we have 18 and a half miles per gallon, or remember that could be written MPG. And we have to make sure that we have a label on our rates, on our unit rates, okay? So our rates start out as a comparison of two numbers, but we do divide them out and get them changed to a unit rate, okay? So Corey earns $52.50 in 7 hours. Find the unit rate in dollars per hour. Again, that's a really important thing. You circle, underline something. You always want to make sure you pay attention to how do they want it. This one they want it in dollars per hour. So what would our ratio look like, our initial setup? Our initial setup, Josh?
$52.50 over 7 hours.
Okay. And again, we're going to include our labels in it. And then you can divide it out. See how much this person is making per hour. Corey is making per hour. Andrew, what's he making?
$7.50.
He's making $7.50. So I'm going to guess if you divide it out, it came to 7.5 on your calculators, right? But do we talk about money as 7.5?
No.
No, we have to add a zero in the hundreds place so we can talk about it as, okay, so $7.50 per hour Corey is making. So one of the things that we want to make sure that we pay attention to again is we can't necessarily go with the order the numbers were in the problem. 12 came first in problem 1, followed by 222. If we would have put 12 over 222 and divided that out, what would we really have been calculating? What would that have gotten us? 12 over 222, 12 gallons over 222 miles. It would have been a decimal, and what would this label have been?
Gallons per mile.
Gallons per mile. Yeah, it would have told us how much of a gallon was used per mile. So it gives it as a different unit rate. But typically, if we have to make the decision, we go with what's more common. Do we talk about gallons per mile, or do we typically talk about miles per gallon, like they asked for in this problem? Okay. Okay, number 3, a car travels 292 miles in 4 hours. What was the rate in miles per hour? Okay, so what are we going to set up in this one? What are we going to set up in this one? Devin?
292 miles over 4 hours.
Okay, you guys agree? Okay. And how do we know that we set it up correctly when we put the labels in it? Andrew?
Because we're asking for miles per hour.
Yeah, and that's how it reads, miles over hours, miles per hour, doesn't it? Okay, so 292 divided by 4 is?
73.
73, so this person is going 73 miles per hour, but what's the typical way we write that? Andrew?
MPH.
MPH, yeah. We might typically see it written MPH instead of MI over HR. MPH, miles per hour. Okay. So unit rates. The most important part about unit rates is to make sure that before you divide it out, you have them set up in proper order. Your answer is going to make sense, okay? So again, we don't typically go to the grocery store and see how many pounds we can get per dollar, do we? So if you're buying, that's why you're going to the candy bin, and candy is, like bulk, you're buying it. Do they show this sign that says you get this many pounds per dollar? Or do they show a sign that says you get this many, you pay this many dollars for a pound? That's how it's typically shown, isn't it? So we want to make sure we always have proper order in our rates. So the dividing out of our calculators, that's the easy part. We got to make sure we have proper order though. Okay, let's go to the back side where now we're going to use dimensional analysis, or in other words, what if, as our second learning goal says, we have to rename the rates. What if we have to rename our rates? So we have a cyclist that's going 56 miles in 4 hours. Find the cyclist's speed in feet per second. So are they asking us for miles per hour? No, they're asking us for feet per second. So let's first of all highlight that. Feet per second, or underline or circle or something. Feet per second is what they want our final answer in this one. But we have to start with what information they gave us. So let's start with our first ratio would be miles, 56 miles, because the distance is first, feet is distance, over 4 hours, because the time is downstairs in the comparison, seconds is time, and we're going to multiply by a conversion factor. Now some of you, you're going to want to do this. This is in here right now because I am insisting, this is what you do, because you will use this in physical science, you will use this next year in biology, you will use it the following year in chemistry. There will be lots of times they will expect you to know how to use conversion factors. So we are going to multiply by a fraction, by another ratio. We're not just going to say, I'm going to multiply by 100 or divide by 10 or whatever. We're going to multiply by conversion factors. So do we need to change the distance, miles and feet? They're not compatible right now, right? That's not what we want. How about the time? Do we need to change that also? We need hours to become seconds. So we have to take care of one or the other first. Which one do you want to do first? Should we do distance since it's upstairs?
Yeah.
Okay, do we have a conversion factor that would convert miles to feet?
Yeah.
Okay, what is it?
5,280.
Okay, 5,280 what? Feet in
1
1 mile. Or we can flip it around and say 1 mile has 5,280 feet. So we have to decide how we're going to use that conversion factor. So that's why on that sheet we wrote it 2 different ways. Because the goal is, when we multiply, you know how when we multiply fractions, we like to cancel things away, right? So we need the miles to cancel away. So where do we want the miles in our conversion factor? In the bottom. So right away just put that and now write the conversion factor. 1 mile has 5,280 feet. We know we want to use it in that order. Because now we just right away we cancel out those miles. We say miles up, miles down. We got multiplication going on in fractions. So go ahead, multiply 56 times 5,280. What is that? Probably some big number. Write it down. Did you get 295,680?
Yeah.
And the label left upstairs is feet. Downstairs 4 times 1. 4. And the label downstairs, left downstairs is hours. Okay, can we be done? We have feet per hour. Can we do our division right now and change it to a unit rate? No, we have feet per hour. We need feet per second. Okay, so I know some of you are going to want to jump and do it with a different conversion factor than I'm maybe going to want you to do, because I want these to be good notes. We don't have to worry about the feet anymore. We need to worry about the hours. So we need a conversion factor that would put hours upstairs, right? because hours are downstairs. We need them to cancel away. So what kind of conversion factor do we go from hours to minutes? Let's go straight to minutes, not right away to seconds. 60 minutes in 1 hour. So we would multiply by that conversion factor. And again, the goal was to get the hours to cancel away. So the only thing we're going to do is cross out the hours, not any numbers, just our labels. Multiply across the top. Well, that's 295,680 still, right? What's its label?
Feet.
They're still feet. 4 times 60. 240, and those are minutes. So if we divided it out right now, 295,680 divided by 240, what would our label be? Feet per minute. We would have a unit rate of feet per minute. Is that what we want? No, so we're still not done. So we'll go over here and we'll write it again. 295,680 feet over 240 minutes this time. And we need a conversion factor that's going to get those minutes downstairs to cancel away, so we need minutes upstairs, don't we? Okay, we're going down in size of time. We went from hours to minutes. What's next? Seconds. Okay, so we're going to have seconds downstairs. What do we have? 60 seconds in
1 minute.
1 minute. That's the conversion factor we want to use. And again, our goal was to get the minutes to cancel away, the label minutes. So now we are going to take 295,680 times 1, and those are still feet. 240 times 60. Devin?
14,400.
14,400, and the label for that is? Seconds. Okay. Are we finally at the label we want?
Yes. Yeah.
Okay, so since we're finally there, do we want to leave it like that? No, we want to divide it out now. Now's when we're going to divide it out. We're going to say, okay, what is 295,680 divided by 14,400? And did it give us round to the nearest tenth? Okay, see what you get. Divide that out, and what's that to the nearest tenth? What do you get, Andrew?
20.53 feet per second.
Ooh, tenth. Sounds to me like you went to the hundredths.
20.5.
10, 20.5, 20 and 5 tenths. It is approximately equal to, notice I use the approximately equal to sign because we rounded, and our label would be feet per second. They may possibly write that as FPS also, FPS, feet per second. So again, it is, okay, I want all of these. Thank you. So again, it is really important that we make sure that we read what do they want it in, and then we use conversion factors. If we use conversion factors, we don't have to look at somebody else and say, should I divide by 1,000 or should I multiply by 1,000? You don't even have to make that decision. The conversion factor takes care of, the conversion factors take care of that for you. Questions on them? We're only going to practice that one. No questions? Okay, then I want you to show a setup of what you think you would do in number 5 to solve that one. Number 5. You just do the first step of work. What do you think you would, how would you attack that problem? Okay, anybody got an idea for me? What did you do? What did you do, Austin?
Multiply both sides by 2.
Okay, you multiplied both sides by 2, okay? Because you're trying to get rid of the denominator on the right side. Okay, so if you take both sides times 2, what would that look like now?
2 plus 6 over
Oh, does the downstairs have to get multiplied by 2 also? No, how do you make 2 into a fraction?
1.
By putting it over 1. 1 times 5 is 5. And notice this set, he did his distributive property. You have to put that in parentheses. The whole numerator has to be multiplied by it. What happens over on the other side?
The twos cancel out.
The 2's cancel out, and we have
And
n minus 1. Okay. Now what would you do? What would be our next move now then? Because everything we've done so far is legal. Did everybody else attack it this way? Is this how you guys went about it? No? What'd you do, Devin?
Well, I multiplied my, what's it called? What I did was I did like
Oh, you forgot what the name of that property is already? Help them out, class.
distribute.
No, I don't think that's what he's, cross products property. Okay, so go ahead and tell me what that would
So
look
I
like.
did 2, and then in parentheses n plus 3 equals 5, and in parentheses n plus minus 1.
Okay. That looks pretty clean cut, doesn't it? Because what are you really gonna have to do next over here, probably, Austin?
multiply both sides by 5.
Now you'd have to multiply both sides by 5, wouldn't you? And if you do that, this has to go in parentheses. And these guys would cancel out. And look at what would happen. We'd have 2n plus 6 equal to, we do our multiplying there. So in reality, in the end, you're still doing that distributive property there, aren't you? And you're doing it over here for this one, and we can go straight to it right there. So cross products is probably the most efficient way to do this one, isn't it? So what you're doing is not wrong, Austin. You can do it that way. It's just going to maybe take you a few more steps. So now, I'm going to use cross products because I love cross products. 2n plus 6 equals 5n minus 5. Am I right? Well, now what? Now what? Did you finish it? You're going to keep going that way? If you want to keep with Austin's way, you can, but then you're finish it. Okay. Josh, now what are we going to do?
You can add 5 to the other side.
Sure I can. Okay. I always love how you guys want to take care of the constants first. I don't really know why, but you do. Okay. That's not illegal. I think there's a bigger issue. What's that issue? Josh,
N minus 2 from the 5.
do you mean 2n?
2 yeah.
Yeah, okay. We got n's on both sides. The real issue is we only want the variables on one side. So I probably would have started there, but you know, I guess eventually Josh is going to do it. So got to get rid of the n's on one side or the other. And so now we have 11 equal to 3n. Am I right? Okay. Now what? Divide both sides by 3. Yeah, you guys are acting like this is new stuff. Maybe it's like, oh, I don't want to have to divide by 3 though, because 3 doesn't go into 11 nicely, does it? Big deal. Who cares? N equals,
3.6.
oh, is it a nice decimal?
No, it's wrong.
Then do we write it as a decimal when it's not nice? That's a repeating decimal. You can't write it that way. So what is that point? 6, 6, 6, 6, 6 that eventually becomes a 7, Devin?
3 and 2.
3 2/3. That would be one way we could give our answer. 3 2/3, but not 3.6 repeating. Josh?
11 thirds.
Or 11/3. We give it that way. Because we can give it as improper fraction as long as there's nothing that can be divided out of a numerator and a denominator. So there's our answer. Okay. In fact, if we were required to do a check problem on this one, you might want it possibly as the improper fraction name for while you're doing the check problem. And trying to check with not a nice decimal, that never goes very well. So Questions at all on the things we did today? Okay, hearing none, I'm gonna let you get started on your homework.